Hey friends, we are in chapter 1 and we're still looking at expressions, equations, and functions, and today we're going to talk about properties. Now I want you to know that everything we're going to talk about you have seen before, you've heard before, you know about it. You might not know the names. So what we're doing is we're really just putting names to things that you've been doing for years. So let's get started. Our first term is equivalent expression. Equivalent expressions are exactly what they sound like. They're expressions that are equivalent. So we have right here two expressions that are equivalent. I'll show you. If I have 8K and then I add to that 3K, altogether I have 11K, right? We remember this from last year, joining like terms together. These are equivalent expressions. So basically one expression can be used in replacing the other. The next term that we have is actually a property in a sense. It's called the additive identity. So basically if I'm walking down the street and I have any old number A, right, and I add 0 to it, I know that the answer is going to be A. I told you you guys knew this stuff already, so don't worry. This is going to be pretty simple. So A plus 0 is A for any number in the world. If I add 0 to it, I get the same thing back. That's the additive identity. Can you guess what the multiplicative identity is? If you have a number A and you multiply it by 1, what do you get? A again. So these properties are really important foundationally, but you guys have been using it all the time. The next property, or the next concept that we're going to talk about is the multiplicative inverse. So we got to think, what does it mean to have a multiplicative inverse? All right. So the multiplicative inverse is simply when you multiply two numbers A and B, and you're going to get 1 as a result. Can you think of pairs of numbers that works for? Well, we know that if I had, let's say, 5 over 3, to get 1, I'd have to multiply by 3 over 5. Can you think of what you would call two numbers that are multiplicative inverses of one another? I hope you guessed it. It's a reciprocal. So a reciprocal is the value. So if A and B are reciprocals, right? If and only if when I multiply A times B, I get the number 1. And so that's it for our basic vocabulary. Now we're going to kind of beef it up and start looking at properties. So we've got properties of equality. Now the first property of equality is going to seem super duper basic, so don't giggle. The reflexive property says that A is equal to A for any number A. I know it seems really silly, but it is a foundational point that we start off with in math. So A is equal to A. If you have a number and you have it and it's 5, 5 is equal to 5. 2 plus 3 is equal to 2 plus 3. 19 is equal to 19. That's the reflexive property. Pretty basic, pretty straightforward. The property of symmetry is not as basic, but it's kind of silly as well. Well, silly to us because we're so comfortable with it. But if A is equal to B, then certainly, wait for it, B is equal to A. That is our symmetric property of equality. Our transitive property of equality is slightly more interesting. So what it says is, if A is equal to B, and if B is equal to some other thing, C, then clearly A is equal to C. You see how that worked? If A is equal to B and B is equal to something else, A has to be equal to that something else, so A is equal to C. And finally, the substitution property is one that's probably going to be most valuable for us this whole year. It's if I have something like A being equal to B, right? So if I had A is equal to B, then if I ever have an expression with A in it, let's say 4A plus 5 is equal to 19. I just pulled that out of the back of my head. It is totally legit, fine, and expected that I can replace A with B, so I can put B right into that same equation. And this is fine, totally legit, and totally makes sense, all right? So that's what the substitution property gives me. And now we're gonna look at properties that are specific to addition, and I'm going to actually add a couple more. Please don't feel overwhelmed. This won't take too bad. This won't take too long and it won't be too bad. The additive identity property, we kind of discussed that before. A plus 0 equals A. The additive inverse property, we did not. The inverse is going to get us back to the identity. So if I had two things, A plus what is going to give me 0. This is what the inverse does. It gets you back to the identity piece. And in this case, the identity value is 0. A plus 0 is A. And to get to 0 as an answer, we'd have to add negative A. So what this is saying is going back to the additive identity, for any A value, if you take A and add 0, you'll get A back. And for the additive inverse, if you take A and then you add its opposite, you get the identity, you get 0 back. So we are almost done, but I needed to add these two on, and I'm going to add it on to the multiplication properties as well. Multiplication and addition can have the quality of having commutativity, and associativity. When I think of the word commute, I think about moving, right? So I can move from place to place. I got to go to work, so that's a commute. So what this says in reference to mathematics is if I have A plus B, that's the same thing as B plus A, meaning it does not matter the order in which I add things together. It's going to actually be totally equal whether I add A plus B or B plus A. So I can move things around, commute, move things around. The associative property is a little bit more involved, but not so much so. It just says I can do certain things at certain times. So it doesn't matter the order in which I add things up. If I've got all addition, I can add A plus B, then add C, or I can add B plus C and then add A, given that the parentheses is telling me what to do first. Does that make sense? So order doesn't matter. And yeah, so the order in which I add doesn't matter, and the order in which I take the numbers doesn't matter. So that's what commutativity and associativity give me. Associativity says it doesn't matter who I associate with first. I know I'm over talking this, but just stay with me. Associativity means it doesn't matter which two I associate together first, and you usually see associativity with the parentheses, and commutativity you see movement. Don't think that this is so basic, because is this true over subtraction? If I were to put subtraction signs in there, would that be true? Think about it. Keep it in mind. Keep it in mind. Little cliffhanger there. We'll talk about that later. Let's look at multiplication, the multiplication property. So multiplicative identity was basically given any A term. If I multiply by the number 1, I'm going to get A back. We talked about that before. The multiplicative property of 0. This is interesting. If I take A and I multiply it by 0, doesn't matter the number, I'm going to get 0 back. This is going to be powerful later. As I said before, I know you guys know all of this, but we're just saying, hey, this is a rule everywhere all the time, and we're writing it down in mathematical form. Finally, well, not finally, because we got to do commutativity and associativity here, but the last thing that I have typed in here is the multiplicative inverse. And so what do I need to multiply by in order to get 1 as an answer? You got it, the reciprocal. So if I have some number A over B, then I'm going to multiply by B over A in order to get 1, and that's always true every day, all the time. I'm going to leave this little section right here to talk about commutativity. So commutativity, if you can remember what we talked about before, the commutative property of multiplication at this time is when we talk about movement, right? To commute is to move, to go from one place to another. So what this says with multiplication is doesn't matter if I multiply 3 times 5 or 5 times 3. It is the same thing. And my final property, associativity property over multiplication, is if I have 2 times 3 times 5, and it says that it doesn't matter the order. I'm going to take these 2 first, then multiply that 5 in, or I can take the 3 and 5 and then multiply the 2. No matter what, I'll get the same answer. And if you think this is silly and basic, can you do this over division? So you see why, so you're catching my question. I asked you about subtraction, I asked you about division. Notice that these 2 properties are particular to addition and multiplication. All right, we're going to get into some really basic examples, and we're just going to see how we always use these properties in general. So if I had to evaluate this expression, what I would do, so evaluate means to get a numerical answer. What I'm going to do is list the properties that I'm using automatically. So the first thing I know I have to do is in the parentheses first, so I'm going to get 7 times 1, right? Because 4 minus 3 is 1, minus 1 plus 5 times 1 over 5. So what is the property I use? Well, I replace 4 minus 3 with 1, so I used a bit of substitution. All right, you see how that works? That's the substitution property of equality. This is an equivalent statement, so I can rewrite it in that way. The next thing I'm going to do is actually multiply. 7 times 1 gives me 7. So what property did I just use there? I used the multiplicative identity. You see that? Because anything times 1 is itself. The next thing I'm going to do is this multiplication over here. When I do that, 5 times 1/5 is going to give me 1. I've used the multiplicative inverse. right? So we use this stuff all the time. We would generally not write it out like this unless you're asked. But yeah, we generally don't do this. And then here, I'm going to go from left to right. 7 minus 1 is going to give me 6 plus 1. And that was a bit of substitution. So I substituted this right here for 6. So I'm just going to put sub down here. And then 6 plus 1 is 7. And that's a little bit more substitution, and I'm done. So you see, we always use these properties, and it's really nice to be able to think through what you're doing. I'm about to rock a property here. Check it out. So if you had this type of money, $6.75, $14, pardon me, $23.25, and $20.50, and you had to add it together, I would look for the most convenient way possible. And what I'm checking out is that I got $6.75 and $23.25, and I know when I take 25 and that 75 together, I get a full dollar. So in my mind, I would like to add $6.75 plus $23.25, right? See what I'm doing? I am moving things around, and I'm using my associative property. So I'm using the commutative property and associative property to simplify my addition, right? Good. So then I do that, and I'm going to take them in pairs. When I add these guys together, I'm going to end up with $30, right? Because 75 and 25 is one extra dollar. 23 plus 6 gives me 29, plus 1 is 30, right? Okay, good. And then the next thing we're going to do is add these guys together, which is $34.50. Now it's pretty simple for me to see that the answer is $64.50. So that's me using the associative property and the commutative property to move things around over addition. Our final example, I know you couldn't wait, was for me to do the same thing with the multiplication. So I'm going to use multiplication properties here, and I don't know about you, if I had to multiply all these together, I would probably look for a shortcut, and the shortcut to me is to use the commutative property and multiply 5 times 2, and then I'll deal with the 7 times 4 later, because 5 times 2 always comes out nice. It's a beautiful 10, and then 7 times 4 is going to give me 28. So from here to here, I use commutative property. I could say that I use associative property here, and then finally I'm using substitution property because I'm substituting values, and finally 10 times 28 is 280. Didn't you think this was going to be the longest video ever? It wasn't. It's not so bad, and I hope this doesn't feel too difficult. Try the examples given in the packet. Do the best you can. If you get bogged down, let me know. Use the notes to answer the questions, because you're going to be constantly asked to say what property are you using when you're solving this problem. I can't wait to see you guys soon. Please take care. Bye-bye.